this video, we are going to be talking about consumer math. So that's basically any problem dealing with money, any problem dealing with you buying something is a consumer math problem. So it's one of the more practical units that we have this year. You've probably heard of all of these words before, and now we're going to really tie those into what they mean and how they apply to certain word problems. So we are going to start with tax, which is basically the money that a state or federal government adds to a purchase to generate revenue. It is money that is added to an original price to find the sale price. So we're going to start out with an original price. We're going to add the tax and get us a sale price, the final price. So the original price of a football is $24.50. The tax rate is 6%. Find the tax and the sale price. So the tax is not 6%, the tax rate is 6%. When we're setting up a proportion, if you are given a percent, we always know we can put that percent over 100 because a percent is just some part out of that 100%. That 100 is the total. So it's some percent out of the total, or 6% out of the total of 100% is equal to, we don't know the tax yet. So we don't know the number on top yet, the number that goes along with that 6%, but we know the total amount, the original price, is $24.50. So now we're going to cross multiply. We want to solve for this x, so we're going to multiply 100 times x. That gives us 100x on one side, and 6 times 24.5, which is 147. So now we have a one-step equation that we want to solve. We want to get rid of this 100 on that side. That's multiplication, so we have to divide it away. Divide by 100 on both sides. And we get that x is 0.147, no, excuse me, that's not right, 1.47. So the tax is $1.47. The tax rate is 6%. The tax is $1.47. So obviously I should have used a calculator when I actually divided here, but I made a mental mistake when originally I was going to say that it was 0.147, which is about 15 cents. That really doesn't make sense as a tax for $24.50. If it's a tax rate of 6%, that's almost 10%. So 10% of that would be $2.45. So if it's almost $2.45, it doesn't make sense for it to be 14 cents. That answer makes much more sense. Make sure your answer makes sense. That is the biggest way, the easiest way to check your answer on these. Make sure your answer really makes sense within the problem. Let's say you thought your answer was $147 as the tax. Well, if the original football only cost $24, that really doesn't make sense as a tax on top of that, which is actually our final step. We are going to add those two together to get our sale price. $1.47 is the tax. That gets added to the original price, which gives us $25.97. So the sale price, the final price, is that $25, almost $26, $25.97. A tip is similar to tax in that it's always added to the original price. It has a different purpose though. A tip is basically money that you give to somebody for good service. So your bill at dinner was $18.80. You tip an additional 15% of the bill. Find the tip and the total bill. So we're going to set this up the exact same way. Anytime you see that percent, you know you can start with that as part of the proportion, 15% over 100, although I do want to get rid of that percent sign because that means something different now. That represents the 15%, and that equals, the tip will be here, but we don't actually know that yet, so that's what we're going to call our x. And the original price, or the total amount, the total original starting amount is $18.80. So now we will cross multiply. 15 times $18.80 is 200, sorry, that is 282. And 100 times x, that's 100x. One last step, dividing by that 100, that gives us that the tip is $2.82. So it's really important that you understand what we just found. Sometimes we'll be asking just for the tip. Sometimes we're asking for the total bill. This is just the amount that we're tipping. The total bill is the tip plus the original amount of the bill, which is $21.62. Again, double check that, make sure it makes sense. That's just a little bit more. It's about $3 more than the original bill, which makes sense for a 15% tip on top of that much as the original bill. Markup is money that is added to an original price to find a sale price. Now this is completely different than the other two. Even though it's the exact same operation, we're still adding. A markup is something that a company will do before the product actually gets to a consumer. So these two, a tax and a tip, are what a consumer pays on top of the sale price. A markup, let's say Amazon, well, Amazon doesn't really buy products, they just are a medium for selling. Let's say Best Buy buys iPhones for $400, and then they sell them for $800. Well, actually, let's use a different number. Let's use 900. The markup here is how much they're increasing this price by. They bought them for 400, they're selling them for 900. The markup is $500. So it's the amount that a actual company increases the price that they're getting them for to make a profit. So Foot Locker buys Jordans for $160. They mark them up 20% to set their sale price. Find the markup and the sale price. So again, we know the percent will go over 100, 20 over 100, and we need to find the markup. We don't know that yet, but we know that the original price here is 160. So we can cross multiply. That would give us 3,200, and that equals 100x. One last step to cancel out this multiplying by 100, we divide by 100, and that tells us that x is 32. So that's the amount of profit that they're making on top of the $160 that they buy them for. They buy them for $160, they increase the price by $32, and they end up selling them for $192. A discount is money that is subtracted. So this is the first time we actually have subtraction here from the original price to find a sale price. A discount is a good thing for a consumer. It means that the price is going down. We're still finding it the exact same way. We have a percent off. We're still using that in the exact same way, 30% off. Coupon for a bag of dog food that originally cost $30. So that is the original price. That's the full amount, or basically thinking about these two as the total and these two as representing the discount. We don't know the actual discount amount, but we do know that that's going to line up with this 30%. Now we're going to cross multiply. That would give us 900 equals 100x. And we divide by 100 and find that x is 9. So the discount is $9. So if I were to ask you how much money would you save, you would say $9. If I would ask you how much would you get this dog food for, this bag of dog food, it would cost you $21 because it originally cost $30. We're saving $9. That gets us down to a final sale price of $21. All right, the last one we're going to go over here is commission. And commission really doesn't get added into anything. Commission is just money that is earned for making a sale. So if you work at a car dealership, if you're a realtor, you make a percent of the sale that you make. A realtor makes 5% commission for every house she sells. She is about to sell a house for $300,000. Find the commission. So commission doesn't get added to the $300,000, it doesn't get subtracted. We just find that number, and that's how much the realtor makes. They don't make any of this money. That's the house. That's what the buyer pays the seller, the 5% is what the realtor will make. Now, to be honest, somebody does have to pay the realtor, but we're not going to deal with that really right now. We're just talking about how much the commission is. So 5% out of 100 is some amount of commission out of the original amount, out of the total of $300,000. So now we're going to cross multiply again. 100x equals, that's going to be 1.5 million. So you can see I've been switching these. The 100x is on the right side of the equal sign here. Now it's on the left side. It really doesn't matter. You're pairing up these two and putting them on one side, and you pair up these two, you multiply those two and put them on the other side. And now we can divide by 100. And that tells us that x is $15,000. So the commission that the realtor would make is $15,000. Now with these 4 questions, the only thing I want to address is what is the question asking. So in each scenario, we're going to circle what the problem is asking you to solve. We're not actually solving the question at all. We're just trying to decide what the question is actually looking for. That is the most important part of this. I feel like once we understand that you put the percent over 100 and the rest of the proportion kind of just fills in from there, the math part of that isn't that tough. But the word problem really takes you some thinking, and you really just have to break down exactly what it's looking for. So I'm actually only going to read the last sentence in each of these because that's really the question part of this. There's going to be information in the first sentence. I'm not saying I want to ignore that, but when I'm looking for what is the question looking for, how much will Pedro tip? That is the only thing I really need. It doesn't matter any of these numbers. Those don't really matter. The 20% actually doesn't really matter. I mean, if we were to find a number, it would need to matter. But how much will he tip? We're not looking for a total. We're not looking for a percent. We're just looking for the amount he will tip. How much money will he receive if he sells a car for $25,700? Actually, I guess we need the context there. It's a 4% commission. So we're looking for the money he will receive for commission. He is a car salesman and he receives a commission. He doesn't get any of this $25,700. He just gets a 4% commission from the car dealership. I guess this really shouldn't be capitalized. Let's lowercase that. If she had to pay an $8 sales tax, what percent? Honestly, I'm done reading. What percent? That is the question. That tells us everything that we need to know. We're looking for the percent. We are not looking for the tax. Actually, we're already told the tax. That's here. We're not looking for the total. Actually, that's there. We're looking for what percent was that. And again, I'm really just reading the last sentence because that is what the question is asking. If she spent $105.60 and had to pay 5% sales tax, how much did she spend at the Apple Store? We're looking at how much she spent. The entire amount that she spent. She's not just spending money on tax, she's spending some money on tax and an additional $105.60. We have the percent already, so we're not looking for that either. We are looking for the total.